All right, our second of 3 parts of this unit are going to be using a lot of proportions, obviously ratios, a lot of proportions, and this is going to help us as we move forward into the rest of this chapter when we're going to eventually be looking at percents, how to turn percents into decimals, and so on, or finding percents of a decimal, stuff like that. This is all going to be super helpful for you because basically all of these can be solved through a proportion. Today we're going to look at how to find missing measures in similar figures. So write this down along with today's date and page number. So your warm-up is solving for those missing values, just as you did in the last unit. So come back to me once you've figured out what the value of n is for every single number. Good luck. Here are the 4 answers I hope you received. So number 1, the missing value was a 3. And you can tell it's half, so what's half of 6? That'd be 3. 6 to 9 would be the same as 2 to 3. For number 3, 4 to 14 is equal to 2 to 7. And 2 to 3 is equal to 6 to 9. So your answers are 3, 2, 4, and 9. All right, let's get rolling with our new stuff today. So the first slide I have here is a big slide of notes. So there's 2 different things that you're looking for with similar figures. You're looking for corresponding sides and corresponding angles. So you want to write down the definitions. So what's a corresponding side? Well, as you can see in the picture down here, we have 2 corresponding sides that are red, 2 corresponding sides that are blue. So we have 3 centimeters is the same corresponding side to 9 centimeters, meaning they're the same size in proportion, not the same exact measurement. And then for line AB, you have 2 centimeters, which is corresponding to line WX. So you can see we have those corresponding. Now the angles are the same side, or with the shapes, the same corners or the same angles as the other side. So because it's a rectangle, every single one has its own corresponding angle, and they all should be 90 degrees. So if we look here, C is 90 degrees. That corresponds with Y, which is 90 degrees. If I was to give you another example, B corresponds with X. So those 2 correspond together. I'm sure you can figure out what A corresponds to and what D corresponds to. So knowing that information will help us as we move forward into example 1. And make sure you have this written down. So the last set of notes here, there's 2 little things that I want you to write down. Talk about what does it mean when something is similar, since we're dealing with similar figures. So similar figures have the same shape, but not necessarily the same sizes. One will be bigger than the other, but as long as everything is equal or proportionate, it'll be similar. So the 2 ways you know a figure is similar is the measures of the angles are equal, and the ratios of the lengths are proportional. So that would mean that they are in equal proportion to both shapes. Have this down before moving on. All right, so let's take a look at these 2 shapes as our first example. You should be writing this in your notes. There are 2 triangles that are similar. We got to find the missing length of Y, and that would mean we're looking for this. And then the missing angle of D. Okay, so let's see what corresponding stuff we have to work with. Well, the measuring of angle D should be pretty easy. C and D are your corresponding angles. And since C is 70, that would mean D is also 70. So angle D equals 70 degrees. So that one's an easy one. But now we got to set up a proportion to solve for Y. So what I always do is I like to start out with the side that we're missing an angle, or missing the length, and create a proportion, or create a ratio. So I'm going to go from left to right. So the small number will be its corresponding side, which is 111. And the ratio to that will be the side that we don't know, which is Y. Okay. So now to make an equivalent ratio, we need to find 2 other similar sides that have enough value that we can solve for that missing letter. Well, one of them that I see that I like because the math looks a little easier is the 200 or the 100 millimeters and the 200 millimeters. So remember, the top numbers are small triangles, so I'm going to make sure my ratio is proper. So I'm going to have 100 to 200. So again, just to kind of show you how we got this, we have corresponding sides of 111 in y and corresponding sides of 100 and 200. And by doing that, we've created a proportion. Now I just have to solve for the y. So y times 100, that's the easy one. That's 100 y. And 111 times 200 seems a little scary, but really we just put the two zeros down, and you're doing 2 times 1, which is 2, 2 times 1, which is 2, 2 times 1, which is 2. So we have big numbers here, but we can narrow these down and make it a little easier. So now that we have our equation, we're just going to solve for that value of y. So we know that the only way to do this is to divide both sides by 100, so that when this is completed, y is all alone, and now we can solve for what's going to go over here. So before we divide, let's notice that they both share a pair of zeros. Zeros there, zeros there. So what I can do is I can just take those off, and we'll pretend that they weren't there. And now look how easy the math is. We just have to see how many times 1 goes into 222, and you guessed it, 1 goes into 222 times. So if we're trying to find the similar length on two triangles that are proportionate, y equals 222, and don't forget to label it millimeters. And that's how you're going to be solving these things, is just using similar sides to create proportions. Angles should be easy. Just look at the number on the other triangle, match it up. Make sure you have this down before moving on. All right, to make this easy for you, we're going to do just number 1. Number 2 is there if you need additional practice with me, and that's what the picture goes with, is number 2. So you don't even have to worry about the picture and everything. We're just going to worry about number 1. Come back when you have found the missing length of x, which is this side of the triangles, and its corresponding angle of g. G's here. There you go. Good luck. Come back when you're done. And hopefully you got the same answers I did. Angle G should have been easy. You saw its corresponding angle was angle C. Angle C was 37 degrees, so obviously G would be 37 degrees. And then when I set up my proportion, I noticed the similar side to X was 12. So my proportion was the left to right, 12 to X, since those are the same sides. And then the other two I chose were the ones going up and down, so 9 and 3. I thought those were easy enough numbers to do, so that was my other set of my proportion. 12 times 3 gave me 36, and 9 times x was 9x. When I divided both sides by 9, I saw 9 goes into 36 4 times, and that's how I got 4 centimeters. So hopefully you got the same answer as I did. All right, so before I move on to this, I just want to remind you that showing your work is important. Some of you may think, oh, I already know it in my head. Well, if you can put it down on paper, that really shows you know it in your head, because you can do all that work. Now, let's look at this word problem, kind of work our way through it. If we look at this, we're looking at similar pictures, but they're proportionate. So it says the reduction is similar to a picture that Kate painted. So Katie painted the height of an actual painting that was 54 centimeters, not a height on this one of 2 centimeters. So what is the width of the painting? Well, what's some of the stuff that we understand? Okay, how are we going to be able to answer this? We know that we're solving for the width of a picture. This little picture is 3 centimeters. We got to find a number that is bigger than that. So we know that this is a reduction, so we know this is a smaller version of our picture. And the reduced painting is down to 2 centimeters by 3 centimeters. So the actual painting is 54 centimeters tall. And the other thing I would add here as a bullet point is the width is wider than it is tall. So the number we're looking for has to be bigger than 54 centimeters. So now that we understand the problem, what I decided to do is make a plan. So I said I have to take this reduced picture of 2 to 3 and figure out the actual, which is 54 times, I don't know. So I put W as width. So once you have that, now all you got to do is work your plan out just like we did with our first example in this video. So I'm going to take the information I know here, and I'm going to create a proportion. So I'm first going to start with the sides that I don't know, which is 3, and I know 3, but I don't know W. So my first proportion is going to be 3 to 5. And then the next thing I'm going to look at is the left to right, 2 to 54. So that's the side I do know. Oops, sorry, not 3 to 5, 3 to W. I don't know where I got that from. There we go. So now I'm just going to cross multiply or cross product, find the cross product of this problem. So 3 times 54, that's going to be our hardest thing. 3 times 4 is 12. Carry the 1. 3 times 5 is 15 plus 1 is 16. So we have 162. And 2 times W is the easy one, 2W. So I'm going to divide both sides by 2 because then that gets us just W alone. So remember, our number has to be bigger than 54, and it has to be proportionate to the 2 to 3. So if I divide 162 by 2, I notice that I will get 81. So the actual width, the actual width of the picture is 81 centimeters. And that's our problem. Just creating a proportion to solve what we got. Okay? Let's get you to do your own. All right, so for practice 2, there's 2 problems, but you can see I only circled one of them. So you have to be able to figure out number 4. It says Lawan swims in a pool that is similar to an Olympic-sized pool. Lawan's pool is 30 meters long by 8 meters wide. The length of an Olympic pool is 50 meters. So to the nearest meter, what is the width of the Olympic-sized pool? Go ahead and create a picture first of what he has to what it needs to be. So if I do that to help you, we can see that the length of his pool is 30 meters and the width is 8 meters. The Olympic-sized pool is even longer at 50 meters. We have no idea what the width is, so I'm going to say X. Okay, and that's what you're going to solve for. Come back when you are done. Now, as you noticed, your problem came out to have some sort of decimal or fraction, and I said just to the nearest meter. The nearest meter would be rounding it down to 13 meters wide. So the Olympic-sized pool is actually 50 meters long by 13 meters wide. And that's the answer you should have found. We're in the home stretch. I have 2 box of thought problems I want you to do. Go ahead and answer these. And here is your quiz. You have 5 questions. You'll see that for these 2 triangles, they're going to help to answer the questions 1, 2, 3, and 4. And then number 5 is on your own. Good luck. We'll see you next time in our next video.